All right, so we've started looking at solving systems of equations. And so let's put up here a 3 by 3 system of equations. All right, so there's our 3 by 3 system of equations. And we went through a kind of a procedure, an elimination procedure to solve that. What we were using in that process was what we call Gaussian elimination. There are certain things we can do to a matrix or to a system that don't change the solutions, that result in equivalent systems, and that those changes are referred to as elementary row operations when we are talking about Gaussian elimination. But before we go down that road, let's introduce some things that are going to start happening from here on out. We're used to seeing x's, y's, and z's, right? But in general, the way we'll write a system from here on out is like this. So instead of x's, y's, and z's, we will have our variables, usually x's, with subscripts. This lets us easily have larger and larger systems. All right. And so, we're already at the end of the alphabet as it is. So this is going to be talking and writing. X sub 2, 7x sub 2 plus 9x sub 3 equals 23. All right, so all we do is we change the x's, y's, and z's to x sub 1's, y sub 1's, or x sub 2's and x sub 3's. There, we'll get it. Okay. Now, what we're going to do is we're going to place this in a matrix. All right, so we're going to use matrices, which so that's going to look like this. A matrix is kind of this array of numbers, and all we do is we grab the coefficients like that, and that's a matrix. Now you notice I haven't put in my second bracket there. Normally I would, right? If I put that in that particular matrix, we would refer to as the coefficient matrix, because the coefficients, it contains all the coefficients of the system. What we'll often do, though, is when we're dealing with systems, is we will also need to tack on the right-hand side as our last column. And then now this becomes what we call an augmented matrix. Whenever you see that augmented matrix, it means it's the coefficients augmented, or in addition to the right-hand side. So that augmented matrix represents the entire system for us. And a lot of times we'll see a dotted line put in here, but we kind of drop that convention. We just say it's an augmented matrix, and so you know that that last row, that last column, is the right hand side. So it's easy to go from a system to its matrix, and from the matrix back to the system. Okay. And so that's our matrix. With once we start talking about matrices, we have a handful of terms that we need to make sure we understand. Each of the numbers in the matrix is an entry, right? So each of those are entries. We talk about the size of the matrix. Sometimes we even talk about the shape of the matrix. This particular one is a rectangular matrix. The size of it, we count the number of rows by the number of columns. So you go down first and then across. So the size here, this particular matrix has a size of 3 by 4. It's a 3 by 4 matrix. Okay, and therefore it's rectangular. A square matrix would be, same number of rows as columns. We can talk about individual entries. So for instance, let's take the 8. The 8 that's sitting right here. The 8 is, we'll label the entries. Well, often we'll label the matrix with a capital letter. So this would be our matrix A, capital A. And then the entries would be the lowercase. So A, and A would be the 2, 2 entry, down 2 over 2. So just for comparison, 7 would be the 2, 3 entry. So we can use subscripts to identify which particular entries we're talking about. Okay. Now, we can, let's talk about just for a second what we mentioned as our elementary row operations. These are things that we can do to the matrix that do not change the solutions, or that give us an equivalent matrix. Okay, they do not change the solutions if it's a system, right? Sometimes we just have matrices that don't come from systems, that are just matrices, mathematical objects in and of themselves. We can perform these elementary row operations and still get equivalent matrices. Okay, so here they are. Some of them are pretty basic, and you can say, oh well, of course that's not going to change anything. I'm going to actually I'm going to go with the, well, let's go through them in order. So multiply, the first thing we can do is multiply any single row by a non-zero constant. And that doesn't change the solutions. That gives us an equivalent matrix. We ran out of room there. Why did we do that? Yeah, constant. We'll squeeze it in there. Okay, so you can do that. We can multiply any single row by anything we want. Now I will say this, we will do that, but remember we can multiply them by fractions. So for instance, I could multiply this row by 1/3, and the reason I might do that is because I want a 1 in that position, right? Messes up everything else, but sometimes we multiply by fractions. The second elementary row operation that we're allowed to do is to interchange any two rows. Notice these are row operations, not column operations. But I can interchange any two rows, and obviously that's not going to change the solutions, right? You're just writing 1 first instead of second. And so those are fairly basic and fairly obvious that we do those things and we don't change anything. The third one is, and this is interesting, I'm going to, look how I write this, add a constant multiple of one row to another. And let me add this right in here, replacing this second row that we are adding to. Okay, now this is kind of important. What we're going to do, and we've done this, but we've kind of played fast and loose with it, and we've been okay. But there are some times when we don't want to play fast and loose with it. Here, the official row operation is to pick one of the rows, say this one, okay, and multiply this row by, say, a -3, and then you add it to this row and replace this row. Okay. Notice we only are allowed in the official elementary row operations to multiply one row by one thing, and then we add to and replace the other row. All right. And that results, that's an official elementary row operation that doesn't change the solutions. What we've often done, and we will continue to do this because this still works, is we will multiply one row by something, say for instance, maybe we'll multiply this row by 2, this row by -3, and add those and replace one of those. That's what I mean by playing fast and loose. It still works, but there are sometimes when we have to restrict ourselves to the official definition. When I do that, when I multiply this by 2 and this by -3 and add them, I'm actually doing this first, multiplying this by 2. No, let's see. I'm multiplying this by -3, and that's just that. Then I multiply this by 2 and add it to and replace that one. So the way that we typically do that is to combine these two whenever you multiply both rows. Now, don't worry about that too much. I'll point out the situations where it's important that you follow this rule. We're okay to multiply, multiply, add, and replace. Okay, and you'll see that as we go forward.